All right, so the second checkpoint, the UDL checkpoint that I'm responsible for, is checkpoint 3.2, which is highlight patterns, critical features, and big ideas and relationships. All right, so we're looking for types of technology that can help us bring out the main idea of a concept. So a few examples are shown below. One that I'm familiar with is illuminations. Which provides virtual manipulatives as an example of highlighting critical features. And the program I'm going to show you is going to be sort of similar to this, just maybe a little more even flexible than that program. So there's a few examples you can take a look at. So without further ado, I'm going to go to Geogebra, which is the site I chose, the one that came to my mind first when I thought about something that really helped me discover big ideas. And it does this in a number of ways. So Geogebra, just like Khan Academy, totally free. It's found at www.geogebra.org, as you can see in the address bar there. And it really has three main features. Materials include a large number of interactive learning and teaching resources. Applications, which can be downloaded on tablets, phones. Basically, the program becomes an extension of, or a more easy to use graphing calculator. And downloads, programs that you can download to your computer. We'll take a look at least the materials and downloads during this screencast. So some of the key features of Geogebra, it's a dynamic mathematics software for all levels of education that brings together, and this is the cool part, geometry, algebra, spreadsheets, graphing, statistics, calculus, and that's all in one easy to use package. So this program connects all these disciplines. It does that by creating an interactive geometry environment, includes built-in spreadsheets, built-in statistics and calculus tools, graphing, sliders, animation, shapes. So we're going to take a look at all these. First, I want to read a couple reviews. So Common Sense Education gave it 4 stars, and CNET gave it 4.7 out of 5. The basic review of this, the basic feeling I got in reading through these reviews is that Geogebra provides a vast amount of flexible math simulations that allow for creation, modification, and real-world learning. However, it does take time for students to learn how to use this software. It's got a steep learning curve, and the content can vary in quality, especially in the materials section. It's an interactive program, but it can be frustrating because it is challenging at times. So let's dig into some of the uses in a K through 12 classroom. We'll explore some things here. So number one, this is a great tool for teachers to use. It allows for, so I'm going to pull up the desktop version, which is the version that I use. A lot. So it allows for construction of shapes. So if I wanted to create a regular polygon here, for vertices, I can just click that in and I've got a square. I can graph a line. I can solve equations, and even has a spreadsheet view right over here. Okay, and so basically this can become an extension of a graphing calculator, which is awesome. All these views, all these tools are available on the desktop version. Number 2, lesson planning. Okay, so let's get back to the site here. We're going to go to materials, and I found this great lesson earlier involving quadrilaterals. Okay, so teachers can actually design activities that explain concepts and support higher order thinking and adhere to the Common Core standards. So this guy here, Tim Brzezinski, created this whole lesson on quadrilaterals. Probably used it in his own classroom and then made it available to this open source here for anyone to use. So let's take a look here. So all of these templates can be used to help students better understand quadrilaterals. And that highlights another use, practice. So the number of GeoGebra applets that are available can really be used by students in and outside the classroom to cover specific concepts. They can take this home and work on it. They can work on their own pace, much like Khan Academy, and get some immediate feedback, which is awesome. So how does this apply to UDL principles? So similar to the Illuminations app, but with more of a possibility of student creativity. So the applets found on the materials page often come with accompanying worksheets that highlight or guide students toward discovering critical features. Through the manipulation and exploration, students will notice patterns that will help them grasp the big ideas involved with the concept they are studying. So let's look at this specific example of this rhombus activity. So what big ideas am I looking for in the rhombus? So you can notice here, I can move these vertices around. No matter what I do, every time I move a vertex, the rest of the shape moves to keep it so it's a rhombus. Okay, so if I'm a student, I'm going to think, what's staying the same here? What patterns am I noticing? What makes this a rhombus? All right. And how do I know to do that? Well, there's actually a rhombus scaffolded investigation activity included right in this resource. So students will measure and display all four sides. What do they notice? They'll construct some segments. And all along the way, what do you notice? What do you notice? What do you notice? Eventually, students will notice some of the critical features of a rhombus. They'll notice that all four sides are the same length. They'll notice that the corresponding sides are parallel. And they'll notice that the diagonals bisect each other, no matter what they do to this shape. So this is just one example of many in GeoGebra of how students can really discover and latch on to those big ideas for themselves. This is not procedural. This is exploratory, which is awesome because it leads to a much deeper understanding of the content. So I hope you've got a good feel for GeoGebra. Any of you math people out there, this is a great resource to use in your classroom. Thanks for listening, guys.